All right, 6.6, we're going to take a look at product sum and power reducing identities. Once again, in this section, I'm not going to go through the proofs of these at this point, just because they can kind of be a little bit long. But and they can't necessarily, guarantee how many times you're going to use these. But once again, throughout this whole chapter, just trying to understand there are different ways that we can break things down. And then later on, it helps us be able to solve that. So I know this is starting to seem like a lot, but I am allowing you to use your identity reference sheets as we move forward here. So let's take a look at the product to sum identities. So product means multiplying, sum means to add, and we work into that as well as finding the difference. And so here we have taking the sine of angle A times the sine of B, cosine of A times the cosine of B. We see all the different combinations here. Sine of A, cosine of B, cosine of A, sine of B. And if you need to, pause it if you need to get those. Otherwise, we're going to go ahead and show how we can simplify or change up this expression here and write it as a sum or a difference. So we have the sine of 3x times the cosine of 2x. So since we're taking sine times cosine, I am going to be looking up on the top here. And we're going to set it up using sine of A times cosine of B. And in this case right here, 3x, that is your A, and 2x is your B. So I'm going to have 1/2 the sine of 3x plus 2x plus the sine of 3x minus 2x. So the nice thing about this now is I can simplify it out a little bit here. 3x plus 2x will give us 5x. 3x minus 2x gives us 1x. And now I could distribute that 1/2. I can take the 1/2 of the sine of 5x. I can't take half of that 5, but I can put the 1/2 out in front. And so here we just took the product and turned it into a sum. Okay, here's another one to look at, the sine of 4 theta times the sine of 7 theta. So sine times sine. Here's the identity that I'm going to use. 4 theta, that's going to be considered A. 7 theta is going to be considered B. So I have 1/2 the cosine of 4 theta minus 7 theta minus cosine of 4 theta plus 7 theta. We can go ahead and do a little simplifying. So I get the cosine of negative 3 theta minus the cosine of 11 theta. Now, one thing I want you to think back to is our odd and even identities. And remember that when you take the cosine of a negative value, it ends up being positive. So as I distribute my 1/2 here, I can actually rewrite this as 1/2 cosine of 3 theta minus 1/2 cosine of 11 theta. Okay, so we can use those odd and even identities here, which makes it nice because you don't have to worry about the negatives then inside. All right, why don't you try and see if you can do this one on your own? Alright, so now that negative 14, just don't worry about it too much yet. You can work on it at the end, but just take it out. Cosine A times cosine B, working that. I've got theta, or not theta, sorry, alpha minus 5 alpha gives me negative 4 alpha. When I take the cosine of a negative 4, remember that's going to be positive. So that's how, as I transfer down here, how this became a positive 4 alpha. And then I did the 14 times 1/2 to get the negative 7 here, and then I distributed that. Now we can also use this 4 is to help us find the exact value of an expression. So cosine of 195 degrees times the sine of 135 degrees. So when I look at this, I don't know what those values are. Once again, using our calculator or using our unit circle, especially when we're trying to find the exact value. So instead, I'm going to look and see if I can try and use one of these identities. So I can set this up as 1/2 the sine of 195 plus 135 minus the sine of 195 minus 135. Now, when I take 195 plus 35, we get the sine of 330. So that's on our unit circle. And then the sine of 195 minus 135 gives us 60. So now you can evaluate this. The sine of 330 degrees is negative 1/2. And then the sine of 60 is the square root of 3 over 2. If I distribute here, I get negative 1/4 minus square root of 3 over 4. And then I can rewrite this as negative 1 minus square root of 3 all over 4. And that would be its exact value. Try and see if you can do this one on your own to find the exact value. You're working with some radian measures, and I mean we do have pi over 4, we just don't have the pi over 12. So try and see if you can get this to simplify to an exact value. Alright, so here you should get negative 2 square roots of 3 minus 2. Simplifying this down, you've got adding and subtracting, so it gives us the pi over 6 and the pi over 3. Negative 8 times the 1/2 gives me the negative 4, and then I'm just going through and solving that way. When I do get down to the end here, I take the negative times the square root of 3 over 2 and negative 4 times 1/2, and I combine that. Just notice that the 2's cancel out, and so I can simplify that down. Alright, so that is the product to sum formulas. Now there's also formulas that go from sum to product. And here they are. You can pause the video if you need to copy them down, otherwise they're on your note sheet. And so what we're going to do is we're going to rewrite expressions as a product, as well as then we can do some evaluating too. So let's take a look at here. Cosine of 8x plus the cosine of 2x. So you got a sum. We're going to try and put it into a product. So cosine plus cosine. So I look up here, and I'm adding the 2. So I'm going to use this identity here. Here's my A, and here's my B. So plugging things in, I have 2 times the cosine. I have A plus B, so 8x plus 2x, divide that by 2. Alright, there we go. And then we're going to multiply that by the cosine of 8x minus 2x, divide that by 2. So now you just have a little simplifying to do. 8x plus 2x is 10x, and 10x divided by 2 is 5x. 8x minus 2x is 6x. Divide that, and we get 3x. And that's how you go from a sum to a product. Okay, here's a new, I don't think I've done this variable yet, but beta, so it's kind of like a little b. Trying to write this. Let me see if there's one. Yeah. So I'll do this one with you. Cosine, or if you want to pause it, by all means, go ahead and try and see if you can do it on your own. Cosine of 3 beta minus sine times 6 beta. Cosine minus sine. So when I look at my options, oops, it's supposed to be, sorry. This is going to create a problem because we don't have one for cosine minus sine. This should be a sine 3 beta. Alright, sorry about that. That should be a sine of 3 beta. Okay, so sine minus sine, that brings us here. So once again, 3 beta, that's A, and 6 beta is going to be B. So 2 times the cosine of 3 beta plus 6 beta divided by 2. Multiply that by the sine of 3 beta minus 6 beta divided by 2. So really not that bad. 3 beta plus 6, so that's going to give us 9 beta over 2. And then you have the sine of negative 3 beta over 2. Now I can go one step further with this. Yeah, because when you take, remember when you take your odd and even identities, the sign of a negative value is negative. So when you take the sine of negative theta, it equals negative sine theta. And so what that's going to do now is that's going to end up making this negative 2 cosine of 9 beta divided by 2 times the sine of 3 beta divided by 2. Alright, try and see if you can go ahead and do this one on your own. And just kind of a little trick that I would suggest maybe doing something with those 10s there to help you. Okay, so negative 20 sine of 4 theta times the sine of theta. I factored out an actual negative 10 to begin with, just so I don't have anything out in front to begin with. Now be aware that that's going to make this a negative cosine of 5 theta. As I work through it here, the negative 10 times negative 2 gives me the 20. But it turns into a negative 20 when we take the sine of negative theta, which is negative sine of theta. So that's where that negative 20 comes into play. Alright, so how do you use this in order to evaluate? And especially working with the exact value. So I have the sine of 340 degrees plus the sine of 75 degrees. So I take a look at my identities. I'm going to use this top left right here. I'm going to keep my 3 halves out in front. And then I'm going to fill everything in. So I'm going to 2 times the sine, and we're going to take 345 degrees plus 75 degrees, divide that by 2, and then we'll take cosine of 345 minus 75, and that divided by 2. We'll see what we get now. 3 halves times 2. That simplifies nicely down to 3. And then I will have the sine of 210 degrees times the cosine of 135 degrees. So we go to our unit circle, and sine of 210 is negative 1/2. Cosine of 135 is negative square roots of 2 over 2. And now if I just simplify, we end up going to get a positive 3 square roots of 2 over 4. Let's take a look at the next one here. And we are trying to evaluate with radians this time. So try and see if you can pause it and simplify it on your own. Right, negative square root of 6 over 2 is what we should get. Really, it's just a matter of kind of working with the fractions at this point. But 11 pi over 12 plus 5 pi over 12 divided by 2 gives me 2 pi over 3. 7 pi over 12 minus 5 pi over 12, divide that by 2, we get pi over 4. So that allows us to evaluate. Alright, we're going to finish up today talking about the power reducing identities. There are 3 of them, so it takes from sine squared, cosine squared, and tangent squared, and reduces the power along with it. This is going to be convenient when you have something like of a larger power, like cosine to the 4th power, sine to the 4th power, something like that. This would also work if you, for some reason, your Pythagorean theorem identities or the Pythagorean identities are not working well. These would be some other options for you to work for. So let me just kind of show you how this works. If I have tangent theta cubed, all right, tangent cubed theta. What I have to do here is that you've got to think about how are you writing this out. You've got to think about that, well, x to the third is x times x times x. And how can I rewrite it even differently? Well, I could do x squared times x. And that's the key part to this, because when I look at tangent cubed, we can think of it as tangent squared theta times tangent theta. So now when I look at what tangent squared theta is now, I have 1 minus the cosine of 2 theta divided by 1 plus cosine of 2 theta. And as far as tangent goes, I can keep it as tangent. You could do sine over cosine, I suppose, if you wanted to. But then this would then be written as tangent theta minus tangent theta cosine of 2 theta divided by 1 plus cosine of 2 theta. Now, it's definitely not simplifying it, it is expanding this. So kind of keeping that in mind, but then you're not working with the exponent as well. Now, let's say you had cosine of 4 theta. Well, you could think about this as written out as cosine squared theta times a cosine squared theta. When you have those squared, then we're going to take 1 plus cosine of 2 theta over 2, and you're going to multiply by itself. And so now if I were to FOIL out my numerator, I get 1 plus 2 cosine 2 theta, and then it would be plus cosine squared 2 theta all over 4. Now the one part here is that we can simplify the cosine squared of 2 theta. And I should actually keep this kind of up a little bit, since you know cosine squared theta is 1 plus cosine 2 theta. Now the one thing you just got to be aware of is that your 2 theta is what is going to go in for theta. So let's shape this up a little bit. Alright, so we're going to have 1 plus 2 cosine 2 theta plus, now I have 1 plus cosine of 4 theta all over 2. Let's see if we look at 4. So hopefully you can see what I'm doing right there, because I'm putting the 2 theta in for theta. 2 times 2 theta gives us the 4 theta. And now I don't have any powers that are in this expression anymore. And I can go ahead and try here and simplify this down. Common denominators here, if I wanted to make that happen, to put these each over 2, then I have to put a 2, and this would have to be turned into a 4. So I'd have 2 plus 4 cosine of 2 theta plus 1 plus cosine of 4 theta all over 2, which is all over 4. You can kind of see where that's going. I'm going to do a little simplifying here. 2 plus 1, well, that gives us 3 plus 4 cosine 2 theta plus cosine of 4 theta. Now this is all being divided by 2. It's then being divided by 4. So we can multiply by that reciprocal of 1/4. Sorry, this is all getting smushed here. So then we're going to get 3 plus 4 cosine 2 theta plus the cosine of 4 theta all over 8. If you wanted to do this as 3/8 plus 4/8 cosine 2 theta plus 1/8 cosine of 4 theta, you could do that too. Alright, let's take a look at this one here, tangent squared times sine squared plus sine squared. So there's a lot going on. Tangent squared x is 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta times sine squared, so 1 minus cosine of 2 theta, divide that by 2, and then we're going to add sine theta, which actually, I'm going to switch this up, make this a little bit easier on myself. So I see that they're both adding. Well, what if I were to factor out a sine squared x? And that would leave me with a tangent squared x plus 1. Okay? So I'm going to do that here to make this a little bit easier on myself. So now I have a 1 minus cosine 2 theta divided by 2 times tangent squared, so 1 minus cosine 2 theta divided by 1 plus cosine of 2 theta plus 1. And now the simplifying tasks begin, which if I'm going to have a common denominator here and I've got that 1, I'm going to make this a 1 plus cosine 2 theta, so then up on top 1 plus cosine 2 theta. So 1 minus. So I'm going to add here, this is going to give me 2, 1 plus 1, and then I have a negative cosine 2 theta, and then I have a positive, so that's going to actually cancel out. So I'm just going to have a 2 over 1 plus cosine 2 theta. And now when I go ahead and do some multiplying, these 2's will cancel. Give me 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. Now, by all means, these are not going to be simplified necessarily. It would make it easier to solve later on, but they will not be necessarily simplified. Alright, so we did sum to product, we did product to sum, and then we did power reducing. So quite a bit. Let me know if there's any questions that you have.